Question 4 is about a block being pushed along a rough horizontal floor, and the mass of the block is 0.8 kilograms. And because it is a rough horizontal floor, we know that there's going to be friction acting. That's why I've drawn the friction arrow on. The question tells us that it is being pushed along by a horizontal force of 7 newtons, and it's going to be in the opposite direction to the friction. The movement of the block, the friction opposes the movement of the block. Then there'll obviously be a weight downwards of 0.8 g, and there's going to be some sort of reaction from the floor going upwards. And part A asks us to calculate the magnitude of acceleration of the block. Now, we're told that the speed of the block increases from 2 meters per second to 4 meters per second in a distance of 4.8 meters. So we know the initial velocity is 2 meters per second. The final velocity is 4 meters per second. The acceleration is what we're trying to find, and we don't know the time, but we do know that the distance travelled in that time was 4.8 meters. So if I'm trying to work out the acceleration, I'm going to use v squared equals u squared plus 2as. So therefore a is equal to v squared minus u squared divided by 2s. Sub our numbers in, I've got 4 squared take away 2 squared divided by 2 times 4.8. Type that into your calculator and you should get an acceleration of 1.25 meters per second squared. And I'm going to label that onto that diagram that I drew up here. It'll be accelerating with 1.25, is that what I said? Yeah, meters per second squared. Then the second part of the question, part B, is asking us to find the frictional force, so finding what F is going to be equal to. Well, I know that F, as in the resultant force, is equal to mass times acceleration. So if I can resolve the forces in the direction of the acceleration, I can work out my missing force. So if we look at the forces going to the right, I've got 7 newtons to the right. Take away F because it's going to the left, and that's going to be equal to the mass, which is 0.8, times the acceleration, which is our answer to the previous question, 1.25. Therefore, we can work out F because F is equal to 7 minus 0.8 times 1.25. I've just rearranged the equation above, and that gives me an answer of 6 newtons. So the frictional force is equal to 6 newtons. So that's question 4. The next question was question 7, and that's this one down here. So it's got these 3 forces acting on a particle, which is of mass 2 kilograms, and it causes the particle to accelerate with a acceleration vector of 3.2 meters per second squared. Well, this one is actually quite a nice simple one. We know that the resultant force in vector form is equal to the mass multiplied by the acceleration in vector form. To work out the resultant force, I just add these 3 forces that are acting all together. So I've got 2 minus 1, add on 3 minus 1, add on A to B, and that is equal to the mass, which is 2 kilograms, multiplied by the acceleration, which is the vector 3.2. Well, here I've got 2 plus 3 plus A, that is 5 plus A at the top, minus 1 plus 2B, that's minus 2 plus 2B. Oh, sorry, actually, this is minus 2B, I made a mistake there. That's a minus 2B, which means this is minus 2 minus 2B. That's my left-hand side. And 2 times 3 is 6. 2 times 2 is 4. Well, if we look at the top line, 5 plus A equals 6. Straight away, I think we can see that A is equal to 1 there. Then the bottom, minus 2 minus 2B equals 4. Well, if I just rearrange that a bit, I get that minus 2B, sorry, 2B, if I take that over to that, is equal to minus 2 minus 4, which is minus 6. And therefore B is going to be minus 3. So I've solved A is equal to 1 and B is equal to minus 3.